Welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Postgraduate Diploma in Computer Applications, PGDCA, New. Semester 2, MCS 207 Database Management Systems. Block-2 Database Normalization and Database Query. Unit-8 Structured Query Language, Part 2. 8.0 Introduction. In the previous unit, you have gone through the details of the basic set of commands of the structured query language, SQL. A good database system consists of normalized relations, which involve the lossless decomposition of relations into smaller relations. These smaller relations have controlled redundancy and help in removing the redundancy-related problems of a database, which you have studied in the earlier units of this course. However, when you want to retrieve information from a database, you may be required to extract information from several smaller relations. Join is one of the most important operations, which can be used to provide information from multiple tables. This unit discusses different types of join operations that can be performed on database tables. In many database queries, you may be required to use a subquery that provides data for the main query. This unit discusses the subqueries and correlated subqueries. The unit also introduces you to the concept of views, sequences, indexes and synonyms database objects. You must practice these queries to master them. 8.1 Objectives. After going through this unit, you should be able to define different kinds of joins that can be performed on tables. Write the SQL statements for join commands. Use subqueries and correlated subqueries. Write nested subqueries. Define and write SQL commands to create views and indexes. Define and write SQL commands for creating sequences and synonyms. 8.2 SQL Joins. The join is an important relational operation for queries that involve more than one relation. You have already gone through the relational join operation in an earlier unit. This unit explains the use of the join operation in SQL. The purpose of join operation is to combine the data from two different tables on specific attributes, which share the same domain. The necessary condition for the meaningful join of two tables is that each of these tables should have at least one attribute, called the joining attribute, that should have the same data domain. The join operation uses the joining condition to combine the data of the two tables. In this unit, we will use the tables and data given in Figure 1 for various examples of join operations. Table name, client, client ID, client name, client address, client phone. COO1 A, B, C, D, 79, MG Road 999999991. COO2 B, C, D, A, Raman Street 999999992. COO3, C, D, A, F, Vindhyachal Apartments 99999999993. Table name, item, item ID, item name, item price, quantity available. I01 pen 20,500. I02 pencil 51,000. I03 paper sheet 21,000. I04 sharpener 5,200. Table name, order, order ID, client ID. O001 COO1, O002 COO2, O003 COO1, O004 COO3, O005 COO2. Table name, ORDERDETAILS. Order ID, item ID, quantity purchased. O001 IO22, O001 IO3 10, O001 IO4 1, O002 IO2 5, O003 IO1 2, O003 IO3 5, O004 IO1 5, O004 IO3 3, O005 IO1 8. Figure 1. Sample tables and data. The tables above do not have a date of purchase, as these tables are just for demonstrating various commands. Please note that the primary key of each table has been underlined. Please also note that each order ID is unique, and an order may contain several items. The foreign keys in the tables are order ID in ORDERDETAILS table references order table. Item ID in ORDERDETAILS table references item table. Client ID in order table references client table. Now, let us answer the following questions about the join operation. 1. Can you join the client and the item tables? No, as there is no common attribute in these two tables on which table can be joined. Please note that two tables can be joined only if they have at least one attribute each which has the same domain. 2. How will you find the name of items that have been ordered by a client, whose name is ABCD? Client ID is C001. In order to answer it, first let us assume that your DBMS supports the clause select into hash. From now, you can find the relevant information in the following way, a very cumbersome way. A. First, find the client ID of the client whose name is ABCD from the client table using the command select client no into #temp client. From client, where client name equals ABCD, the output of this query would be a temporary table named #temp client. As per the data of figure 1, the only client ID with the name ABCD is C001. Thus, the output of the command above would be table name #temp client, client ID C001. B. Next, you can find the orders made by client ID C001 from the order table using the command select order ID into #temp ordar. From order, where client ID in select from #temp client, the output of the command above would be table name #temp ordar, order ID O001, O003. C. Next, you will find the items that have been ordered in each of the order ID O001 and O003 from the ORDERDETAILS table using the command select distinct item ID into #temp order details. From order details, where order ID in select from #temp ordar, the output of the command above would be table name #temp order details, item ID I02, I03, I04, I01. D. Now, you can find the name of the ordered items by C001 from the item table using the following command select item ID, item name. From item, where item ID in select from #temp order details, the output of the command above would be item ID, item name, I02 pencil, I03 paper sheet, I04 sharpener, I01 pen. Figure 2, the output of the command. Can this query be answered with a single query? You may require the join command to solve this query. Select distinct item ID, item name. From client C, order O, ORDERDETAILSU, item I, where C, client name equals ABCD and C, client ID equals O, client ID and O, order ID equals U, order ID and U, item ID equals I, item ID. Though the statement above looks very complicated, you can interpret it by the following statements. In the select statement, you have put the information that you want to output. The item name information is available in only item table, whereas item ID is available both in item details and item tables. Thus, the alias I before the item ID is necessary and informing the database server that item ID data is to be obtained from the item table. Please note I is an alias to item table. In the from clause have used aliases for every table that is being used. The where clause has the following conditions. OC, client name equals ABCD, which will identify the client ID as C001. OC, client ID equals O, client ID will join the client table, alias C, with order table, alias O, and output O001 and O003. OO, order ID equals U, order ID will join the order and ORDERDETAILS tables. OO, item ID equals I, item ID will join the ORDERDETAILS and item tables, thus producing the final result, as shown in figure 2. This example may seem to be very complex, but you must once again go through the example after going through the remaining part of this unit. Now, let us now focus on different kinds of joins. 8.2.1 Equi-join. Equi-join, as the name suggests, has equality as the joining condition. This means that the attributes that you are using to join would be checked for equality. Please note that the names of the joining columns in the two tables may be different. The following is an example of an equi-join operation. Example 1. Using the tables of Figure 1, answer the query. List the ID, name of the client, and the order IDs of all the clients who have placed an order. You need to use the client and order tables to answer this query, as the name of the clients are in the client table and the order ID information is in the order table. You may use equi-join operation for this query using the columns client no in client and client no in the order table. Though in this present example, both the columns have the same name, i.e. client ID, equi-join operation does not require these names to be the same. SQL query for the query is presented below. Query using equi-join. Select C, client ID, C, client name, O, client ID, O, order ID. From client C, order O, where C, client ID equals O, client ID. The result of the query, on the tables of Figure 1, will be C, client ID, client name O, client ID, order ID. COO1 A, B, C, D, COO1 O001. COO1 A, B, C, D, COO1 O003. COO2 B, C, D, A, COO2 O002. COO2 B, C, D, A, COO2 O005. COO3 C, D, A, F, COO3 O004. The output of shows the client ID of both the client and the order tables. We can display any one of these two columns. Please also note that joining may result in the display of redundant information, as you can observe in the client name column. Natural join. Natural join is one of the most used join operations. It requires that the joining columns of the two tables should have the same name. It uses the equality condition. The result of the join operation displays only one of the joining attributes, columns. The query of example 1 can also be answered using the natural join operation, as both the tables have the same column name client ID. The following SQL command will perform the natural join operation. Select client, client ID, client name, order ID. From client natural join order, the output of the command would be client, client ID, client name, order ID. COO1 A, B, C, D, O001. COO1 A, B, C, D, O003. COO2 B, C, D, A, O002. COO2 B, C, D, A, O005. COO3 C, D, A, F, O004. Inner join. Inner join combines two tables using a combining condition on the joining attributes. In the present versions of SQL, you may have to use inner join command for example 1 query. Select client, client ID, client name, order ID. From client inner join order. On client, client ID equals order, client ID. 8.2.2 Outer join. Consider the situation that a new client has been added to the client table and the present state of the client table is table name, client, client ID, client name, client address, client phone. COO1 A, B, C, D, 79, MG Road 999999991. COO2 B, C, D, A, Raman Street 999999992. COO3 C, D, A, F, Vindhyachal Apartments 99999999993. COO4 D, A, F, G, Medan Road 99999999994. Further, assume that this new client has not issued any order. Let us now issue the query of example 1. Again on the present state of the database. You will find the result of the query will still be the same as shown in example 1. So, we get no information about COO4 in the result of the query. If the objective of the query was to show the list of all the clients and their order IDs, irrespective of the fact that they have given 0 or more orders, then how would you extract such information? In effect, you want that all the records from the client table should participate in joining even if there is no Joining row in the order table. This requires the use of outer join operation. Example 2. List all the clients and their orders, null in case no order is given by a client. The following SQL command will be required for the query asked above. Select client, client ID, client name, order ID. From client left outer join order. On client, client ID equals order, client ID. We have used the term left outer join, as in this command we want that all the records of the table mentioned on the left side of the join command, client in this case, be part of the output, irrespective of a joining record on the table on the right side, order in this case. The output of the command would be dot client, client ID, client name, order ID, COO1 A B C DO001, COO1 A B C DO003, COO2 B C D AO002, COO2 B C D AO005, COO3 C D A FO004, COO4 D A F G null. You may notice that the last record in this table is for client COO4, who has not placed any order yet. This record is displayed as we have used the left outer join operation. Similarly, you can use the right outer join or full outer join, as per the need of database output. 8.2.3 Self-join. In the self-join operation, a table is joined with a copy of itself. This is very useful for queries which draw information from within a column of a table. The following is an example of the self-join. Example 3. Find the pairs of similar priced items in the item table. You may first simply inspect the item table. You will find that pairs pen and paper sheet, and pencil and sharpener, have the same price. How did you find this information? You compared the item price of each item with other item price. This inspection, in general, can be performed by join operation. Hence, you can answer the query using the following SQL command. Select I1, item name, I2, item name. From item I1, item I2, where I1, item price equals I2, item price. Thus, you are joining the two tables on identical item price, and displaying the pair of names of the items that have similar prices. However, you will get the following output of this SQL command. I1, item name I2, item name, pen pen, pen paper sheet, pencil pencil, pencil sharpener, paper sheet pen, sharpener sharpener, sharpener pencil, which are responsible for joining the data from two tables. Nested queries are used when the output of a query may be useful for the execution of another query. Thus, you can create a main query nest, a subquery in any of the clauses of this main query. In this section, we discuss the basic type of nested queries and then a special type of nested subqueries called correlated subqueries. 8.3.1 Subqueries. A subquery is another select statement that is used in the main select statement. Please remember the following points about a subquery. A subquery is executed prior to the main query. Therefore, you can use the result of a subquery in an expression of the main query. A subquery, on its execution, can return either a single value or a set of values or a relation. Therefore, the result of the subquery can be used in a comparison in the where or having clause or for comparison with a set operator, or even in the from clause when a relation is returned. You can put a subquery inside a subquery. You can use a separate table in the main and subquery. You should not use the order by clause in a subquery, rather it should be used as the last clause of the main query. However, you can use the group by clause in the subquery. When you use subqueries in the where or having clause of the main query, you may be required to use comparison or set operators. Some of these operators are given below. Comparison operators equals, select quantity available from item, where item ID equals I01. There are two subqueries in this case. The output of the first subquery would be value 5 and the output of the second subquery would be value 500. The result of the query is given below. Item ID, item name, item price, quantity available. I03 paper sheet 21,000. Example 7. Find the total quantity of all the items in every order. This query can be answered by the ORDERDETAILS table using a simple group by clause. Select order ID, sum, quantity purchased, AS total of all items. From order details, group BY order ID total of all items. 0001 13, 0002 5, 0003 7, 0004 8, 0005 8. Example 7. B. Find the total quantity of all the items for the orders, which have ordered more total quantity than ordered in order 0003. Select order ID, sum, quantity purchased, AS total of all items. From order details, group BY order ID. Having sum, quantity purchased, greater than, select sum, quantity purchased. From order details, where order AD equals 0003. Please note that the subquery in this case is in the having clause. This command will output order ID total of all items. 0001 13, 0004 8, 0005 8. Example 8. Find the total price of each order. This query would require joining of ORDERDETAILS table and item table, as the details of an order are in the ORDERDETAILS and price of each order is in item table. The following command would simply compute the price of each item of the order. Select order details, item name, item price, quantity purchased price, AS item total. From order details, item, where order details, item ID equals item ID. This command will list the orders as under order ID order details, item ID quantity purchased item name item price item total. 0001 IO2 2 pencil 510. 0001 IO3 10 paper sheet 20,200. 0001 IO4 1 sharpener 55. 0002 IO2 5 pencil 525. 0003 IO1 2 pen 2040. 0003 IO3 5 paper sheet 20,100. 0004 IO1 5 pen 20,100. 0004 IO3 3 paper sheet 2060. 0005 IO1 8 pen 20,160. To find the answer of the stated query, you need to find the sum of item total for each order. Thus, you can answer of the stated query by the following SQL command. Select order ID, sum, quantity purchased price, AS order total. From order details, item, where order details, item ID equals item ID. Group BY order ID. This command will list the orders as under order ID order total. 0001 215, 0002 25, 0003 140, 0004 160, 0005 160. Example 8. B. Find the total price of the orders, which have at least one order for the item whose item name is paper sheet. This query would require you to use the answer of the query 8, and use of join in the subquery. The answer to the subquery would be a set of records, therefore, we will use set operator in. The query is given as follows. Select order ID, sum, quantity purchased price, AS order total. From order details, item, where order details, item ID equals item ID and order ID in. Select distinct order ID. From ORDERDETAILSU, item I, where U, item ID equals item ID and item name equals paper sheet. Group BY order ID. This command will list the orders as under order ID order total. 0001 215, 0003 140, 0004 160. Example 9. Find the hidden name of all the clients who have ordered pen and paper sheet in a single order. This query would require the joining of the order table and client table in the main query and the order details table and item table in the subquery. The following command would find the list of order IDs, which have both pen and paper sheet in a single order. Select distinct order ID. From order details, item, where order details, item ID equals item item ID and item name equals pen. Intersect. Select distinct order ID. From order details, item. Where order details, item ID equals item ID and item name equals paper sheet. This query will result in the following output. Order ID, 0003, 0004. Now, you can write the query as follows. Select distinct, client ID, client name. From order, client. Where order, client ID equals client ID and order ID in. Select distinct order ID. From order details, item. Where order details, item ID equals item ID and item name equals pen. Intersect. Select distinct order ID. From ORDERDETAILS. Item. Where order details, item ID equals item ID and item name equals paper sheet. This command will list the client's information as under. Client ID, client name. COO1 A B C D. COO3 C D A F. Example 10. List the total price of the orders, whose total price is more than 150. An alternate way of writing this query would be to use a subquery in the from clause, as given below. Select order ID, order total. From, select order ID, sum, quantity purchased price, AS order total. From order details, item. Where ORDERDETAILS. Item ID equals item ID. Group BY order ID. Where order total greater than 150. Order ID order total. 0001 215. 0004 160. You may please note that an alias in the subquery is used in various clauses of the main query. 8.3.2 Correlated subqueries. In many queries, the columns of the tables used in from clause are also used in the subquery. Such subqueries are called correlated subqueries and generally are time-consuming queries. These queries are explained with the help of the following example. Example 11. List the client ID and name of the clients who have ordered item ID I01 and item ID I03 as part of a single order. This query can be answered as a correlated query as follows. Select distinct order ID. From ORDERDETAILS outer. Where order details, item ID equals I01 and exists. Select distinct order ID. From ORDERDETAILS inner. Where outer, order ID equals inner, order ID and outer, item ID 15. This will create the view consisting of two items I01 and I03. Assume that the price of the pen is discounted and made 10 rupees. If you allow an update through the COSTLYITEM view, then the price of item I01, pen, will be updated to 10 Indian rupees. Thus, I01 will no longer be part of the view and disappear from the view. The situation may be avoided if you use with check option, which will restrict such updates. Thus, you may use the following option to create the view. Create view costly item AS. Select from item where item price greater than 15. With check option. 8.4.2 Sequences. Consider a situation where in a column you want to assign the next number in a sequence in every new record. Sequences are used for generating a new unique number of a sequence for a specific column. Sequences may be used for automatically generating the unique primary key values, as they can be generated efficiently. The following example explains the use of sequences. Example 14. You can create a sequence, say ENRSEQ, for generating unique enrollment numbers of the students as follows. Please note different DBMS may have a different command for such sequences. Create sequence ENSC. Start with 230 million and 1. Increment by 1. Max value 239,999,999. The SQL commands, as given in example 14, will generate the sequence numbers ENSC, but how will you use these sequences in tables? This is explained in example 15. Example 15. This example demonstrates the use of sequence numbers while inserting records in a table. Consider a relation student, student ID, student name, student proc code. The student ID is the primary Key of the relation n should be unique and 9 characters long in the range 230 million and 1 to 239,999,999. 2. Automatically generate the sequence of student IDs. You may use the following command. Insert into student values, ENRSEQ, next wall, ABCD, PGDCA. Insert into student values, ENRSEQ, next wall, BCDE, BCA. Insert into student values, ENRSEQ, next wall, CDEF, PGDCA. You can display the content of the table after these insertions using the following commands. Select from student, student ID, student name, student proc code, 230 million and 1 ABCD PGDCA, 230 million and 2 BCDE BCA, 230 million and 3 CDEF PGDCA. You may please note that all the details of a sequence, like starting number, increment value and maximum values are stored and updated from time to time in the data dictionary. Further, certain situations like the rollback of an insert operation may result in gaps in the inserted values of a sequence. Can you modify a sequence once created? Yes, for this purpose, you may use the alter sequence statement of SQL. For example, you can change the increment value to 5 and the maximum value to 235 million for the sequence ENRSEQ using the following command, the alter sequence ENSC. Start with 230 million and 1. Increment 5. Max value 235 million. You can also delete a sequence by giving the following command. Drop sequence ENSC. 8.4.3 Indexes and synonyms. An index is part of the physical, internal schema of relational design. It is one of the important access structures of a database. Indexes help in enhancing the speed of the query processing. Every database has a basic set of indexes, like the primary key index, which are created automatically by the database management system. Additional indexes can be created by the database administrator, if needed. You can create indexes using the following command. Example 16, consider the student relation, as given in example 15. You need to create indexes for I, to enhance the queries related to various programs, E, to list the students of a program in the order of their names. For this case, you may like to create an index on program and student name. You can use the following commands to create these indexes. Create index proc code _IDX on student, student proc code. Create index PROGSTUDENT on student, student proc code, student name. It may be noted that the information of the indexes of the tables is stored in the data dictionary of a DBMS. Further, you may note that though an index may help in improving query response time, they increase the time of data insertion, modification, and deletion, as these operations require updating the contents of related indexes. In general, you cannot modify the structure of an index, however, you can delete an index. To remove an index, you may give the command drop index PROGCODEIDX. Several DBMSs allow creation of alternative links or names to the database items or objects. These alternative names are generally short names and used for convenient references. For example, a typical DBMS may allow the creation of short names using the following command. Example 17. You may create the following synonym for the student tables of example 15. Create synonym saint for student. You can remove a synonym by giving the following command. Drop synonym street. 8.5 Summary. This unit introduces you to join queries and subqueries. First, the unit explains the use of the join statement in SQL. A join statement uses two tables, each of which has at least one attribute on the same domain. These attributes, also called joining attributes, are used to join the tables using a conditional operator. In case this conditional operator is equality, then the join operation is called the equi-join. In addition, if the joining attributes have the same name in both the tables, then only one of these attributes is included in the output. This type of join is called the natural join. Outer joins are used when the records of the table, which do not participate in join operation, are to be output to Self-join is performed when one column values are to be related to the same or another column of the same table. The joining condition of self-join requires removing redundant records. The unit discusses these joins with the help of examples. Next, the unit discusses the nested queries. The unit details some of the simple operators that are used with subqueries with the help of examples. This unit also discusses the correlated subqueries, which are generally expensive to execute. Finally, the unit provides details of some of the important concepts used in database management systems such as views, sequences and indexes. You should practice these queries using a DBMS. Thank you for watching. We will see you in the next video with the next chapter.